Am I audible? I don't know why my camera is going off again and again. Children, we'll wait for 2 more minutes and then we can start off. So only three students, right?
Are you able to see my table? Hello. Am I audible? Okay. Good. Okay. So we'll start off building HCC in the PrayogPeti box. You will basically Am I audible? Am I audible? Okay, fine. Yeah, I'll start off. Okay, the first step is what I do is there's a small piece like this, which I would be attaching it here. Little tight. Okay. Okay. Okay, so what I'm doing is I'm going to just insert it through this.
Okay. You can see this. Okay, I'm attaching it here. So similarly, you'll be doing it like using the paper. Okay, I attach it on one side, and now I'm trying to attach it on the other side. Just bear with me for today because somehow, like I see that the video is going off again and again. I'm not sure why. Okay. Okay. So I built a base. Okay. On top of this, I am going to attach this. You can see there are some numbers written on this. Okay, these numbers are nothing but, you guys can guess it or I'll tell it at so what I'm doing is I'm matching this central cut to this center line that is marked here. Okay, this is basically it's this design which I'm doing is it basically works for Pune very well. Okay, so that's one thing, and then actually one more piece across. Okay, I'm attaching it across. This is little tricky because it's very delicate to handle. I should not press it hard, else it might break. Okay, I think it has gone enough inside, but I'm trying to fit in hard. Okay, fine. Yeah. So this is done. Okay, this is done, and I'm going to attach these rings here. Okay, 1, 2. Okay. So now this is a basic sundial setup, but we need to add something very important to this. So it's the stick. Okay. So this stick plays a very important role in showing us the time. I'm just turning it, inserting it such that the stick comes to the other ring. Okay, so now what happens, children? See, even on this strip, I'm not sure if you can actually see it. There's some markings. Okay, there are some markings which says 6 to 18. So any idea what you mean by 6 to 18? Can anybody tell me what it can be? 6 on one side it is 6 and the other side it's 18. Can anybody tell me what it could be? Okay, children, this is basically this is the time. Okay, so we have marked the time from like 6 a.m. till like 18 p.m. That means 6 p.m. 6 a.m. to 6 p.m. Okay, and this stick is the one that is going to show us the time. Okay, so when the sun rises, so we need to place this such a way that we need to place it such a way that this is pointing north. Okay, if this is north, this is east. Okay, this is west, right? So the sun rises from the east and sets on the west. Okay, when the sun goes up, what happens? The sunlight falls on the stick, and the shadow of the stick will fall on this C cut. Okay, so on this we have marked the time. Okay, on this we have marked the time, and you'll see that the shadow will exactly fall on the on the time. Maybe there's a 15 minutes different, but it can accurately show you like it can show you the timing at an accuracy of like maybe 10-15 minutes. Okay, so with this setup, actually one of my friend, I had given this setup after the initial design. So what he did was he kept this in the sun for the entire day. He kept this in the sun for the entire day, and he monitored the time, and he showed that like there slightly there's about like 10-15 minutes difference between the actual time. Okay, so I'll just show you how it works. And for showing it for now, what I've done is I'm taking a torch. I'm taking a torch and putting it here. You can see that. I'm not sure if you're actually see. You can see that the stick shadow is falling, right? Okay, the stick shadow is falling on this as well. See, the shadow is falling here right now. So that means here it is 10 o'clock. Okay, so as it moves, what happens? The shadow comes to the center. Center, it's like 12 o'clock. Shadow comes to the center and it's 12 o'clock. And as it moves towards like when the sun sets, it's close to about 6 o'clock. Okay, this is the shadow which the shadow of the stick falls on this. So that basically tells us the time. Okay, so now, so I had few questions. You guys can ask me some questions in case you have. Now, else I'll start asking you a few questions. Okay, so you guys can start asking some questions to me in case you have. So this is a fantastic setup. I love the setup for a simple reason that so generally we know that when we are doing multiplication, when we look at the clock, we need to know the multiplication table, right? We need to the multiplication table for 5. Okay, so if the longer hand is on 2, that means it's 5 2s are 10, right? So but this is an amazing time machine. We cannot call it as a time machine, but a machine that can show us the time. Okay, so this even without knowing the multiplication table, by just understanding the shadow where the shadow is falling, and if you just know how to count the numbers, you'll be able to just counting of numbers or identification of numbers is more than sufficient to find the time using this. Okay, this we call it as a sundial. Sundial is there in Delhi's Jantar Mantar as well. I think that's a popular place. In Jantar Mantar, we have time sundial. And apart from that, sundials have been used like historically in the mostly in the Arabic countries. Okay, for them because here, like I think, like in India at least, like we are pretty much advanced why there is a middle stick? Yeah, middle stick. That's what the middle stick is basically. The shadow of the middle stick falls on the sea, so that's what. Then that tells us the time. Okay, the middle stick is very important. Without that, we won't be able to what do you say? We won't be able to see the time. Okay, so the other things are just arrangements. Arrangements. The actual time is shown on by the middle stick. Okay, but the other things are the markings which are important for us to show if the shadow falls to identify what the time is. Okay, good. So other important thing is you can see that on this, on the bigger C, you see that there are numbers. So right now I put a number. I'll tell you, read the number for you. It's 18.6. 18.6 is the mark where I have inserted the smaller c. Okay, so 18.6 is the latitude for Pune. Okay, it's a latitude for Pune. That means, so if you take the same setup without disturbing anything, if you take it to Delhi, it's not going to work, or take it to any other place, it's not going to work, because every place has its own latitude. Okay, if it doesn't work means that like again there would be a difference of like 10-15 minutes. Okay, so that's what happens, because for us latitude is not a problem, longitude is the problem, because you know that from from West Bengal till is on this side like Rajasthan or Gujarat, there's a huge gap. Okay, there's a huge gap. So then there is a difference of almost close to 15 minutes of by the time the sun rises. Sun is seen on the in West Bengal and the sun is seen in Gujarat. Okay, there's a difference of about like 15 minutes. That's the whole reason they have fixed Calcutta to be the just a minute. I think I'll just check what is the reference point for time in India. Point for time in India. The clock tower in Mirzapur in UP. Mirzapur near Allahabad. Okay, fine. Okay. Okay, so there's a place called Mirzapur in Allahabad. So that is where we take the time reference. Okay, so we see that like that becomes the time when the sun rises and sun sets for us. So now, so that's the whole reason, because Mirzapur, like Uttar Pradesh, is almost comes exactly in the center of India. So longitude is not a problem for us. Latitude is the problem. Okay. So if you go upper, so suppose in Kanyakumari, it's a different latitude. Okay. As you go to Kashmir, it's completely a different latitude. Okay. So when the latitude changes, what should happen is this C curve is there, right? You need to continuously shift that C curve. This particular the bigger curve on which there is marking for the latitude. You need to basically continuously shift this to the latitude of that particular place. Okay, so then what happens is that you'll be able to get the time of that place. Okay, that's important. Okay, so other thing, children. So I wanted to ask you, how does the day and night happen? Any idea? Can anybody tell me how the day night happens? Oh, you just joined. How come you're late today? Oh, is there anybody who wants to ask me some questions? Anybody who wants to ask me some questions, please tell me. If you ask questions, that basically encourages me to do more experiments. Today I have planned 2 experiments basically. Okay, please tell me any questions about the sundial. Please tell me. So this works on a very basic principle of like lights and shadow. Okay, just about where the source of the light is there and where the object is there. So depending on that, the shadow will fall somewhere. Okay, based on where the shadow falls, we basically try to understand. We Okay, so OJS is telling if you can sum up the things again. Okay, I can do that. It's very simple. It's very simple. Basically, I was basically showing the construction of this sundial. This we call it as a sundial. So the best part of sundial is that sundial can basically show the time even if we don't know the multiplication table, right? So we know that, like, we understand that the multiplication, we need to know the multiplication table for 5 to think of to even read the time, right? To read the time. But this has numbers. If some small children, like, who just know how to identify the numbers, even they will be able to sort of they will be able to tell the time based on where the shadow falls. Okay, so this tick in the center is the one that is basically helping us, because when the sun is here, what happens? The sun ray falls on this, and there is a shadow exactly in the line of that ray, right? So then that becomes the marking near that, whether it's 10 o'clock, 11 o'clock. So based on that, we can tell the time. Okay, so this is a very simple sundial device. Okay, so which they had used it in, like, ancient days to understand the time, to know the time. Okay. Yep. Okay. Fine, children. Any questions, please? Others, you can ask me questions. There's one more question. Yes, of course. I said that, like, it can be made by other material. You don't need this. I used to do it using the cardboard. Just the cardboard is also fine to do this. So actually, in this PrayogPeti box, I don't know, like, I'm not very sure of which class. Either it's for 6th or 7th. I'm not very sure for which class. You basically get a sheet, a cardboard sheet on which we have the print of this. You can just cut and remove these components, and you can start making your own sundial. Simple. Okay, but in case you want, you can also do it on the cardboard. You can use the cardboard. So what I will do is, after this class, maybe like either today evening or tomorrow, I'll send you an, like, A4 size PDF file, so which you can print it and stick it on the carton box board, the brown color board, right? The carton box board. You can stick it on it, and then cut out the shape, and you will be able to build your own. Simple. Okay. Any other questions, children? Please ask me. Any other question? I really like this one. Also, this, because for the way it looks, and also that you can read any person, even who has not even gone to school, and they know just to identify the numbers, they'll be able to they will be able to tell the time. Okay, that's the best part of this. Okay, children, so I want you to ask questions. So actually, I have planned for one more experiment where I wanted to show you. It's a continuation of last class, actually. It was a continuation of last class. I wanted to show how electrically to how can we determine electrically whether in water is, like, acidic or what. Okay, so I wanted to do that experiment, but yeah. So the important thing is, I wanted to have a good interaction with you guys, but you're not turning on the camera, first thing, and second thing is, like, I'm happy that you're writing questions, but I would be happy in case you ask me. Oh, this can 10 minutes, maybe 30 minutes. Okay, and you need to understand, because right now there is a mark on this. For suppose right now it is 11 o'clock, right? There is 11 o'clock, 11:30 there is a mark, and, like, then there is 12 o'clock mark. So you have 30 minutes. If the shadow is between, like, 11 to 11:30, if the shadow is between 11 a.m. to 11:30 a.m., that means you can consider it to be 11:15. Simple. So, but 11:15 is one, like every 1 minute, 2 minute, or 5 minutes would also be difficult to determine from this. Okay. So as I said, this sundial was used in the ancient days. Ancient days for them, they would be very happy even if they know like when the sun can, when the sun rises, sun sets, and when it is the midday. So these three important times were very important for them. Okay. But wanted to have like times in between as well because they wanted to plan their work and all those stuff. So then they required like they started making something like this so that they just don't need don't they just don't want to see the sunrise, sunset, and the midday, but they want to see the times in between. That's when they started doing something like this. Okay, they started using the position of the sun and the shadow of an object to determine what would be the time. Okay, the other way people used to do the time machine was, the clock was, you had that inverted, I'm sorry, that we used to have a sand kind of glass inside which there used to be sand. You flip it on the other side, the sand continuously flows out. That's one type of sign. But I don't know if you guys have seen Aryabhatta or read about Aryabhatta. Aryabhatta had designed a water clock. Okay, you can basically go online and look for that water clock. It used to drop. It used to drop water at every 1 second, exactly 1 second. So then what he did was he said that he had poured some amount of water, and he had asked his daughter. Basically, it was basically his daughter's marriage. He had built this water clock, and he said that, see, as soon as the water stops dropping from this, you can come to that like venue where the marriage was happening. Okay, so he had started the clock and he left, and like what happened? Uh, so the what some something happened. Just a minute. I'm telling the reverse or whatever. I don't know. Oh, no. Sorry. What happened? The water was dropping under which he had kept a bowl. Okay, he had said that once that bowl fills up, she can come to the what venue. So she was her daughter. His daughter was waiting for the venue for the bowl to fill up. So, but the bowl was not filling up. So then it got late, and actually the bridegroom people actually they got pissed off. So they were upset and they left. Okay, then like even Aryabhatta was very upset. He came back. He came back to see. Just a minute. I was just trying to confirm something because it did not happen that I give you the wrong detail. Because okay, I'm very sorry. That's the reason I myself had this doubt. Okay, so this was not Aryabhatta, this was Bhaskaracharya. Okay, I'm sorry. Bhaskaracharya, what he did was, I said you the story, right? He had created a water clock and he wanted his daughter to reach the marriage venue when the bowl under it fills up. Okay, so but the daughter did not go to the marriage venue, and the bridegroom and those people they were upset and they left. So then Bhaskaracharya himself was upset why the daughter did not come there. So he came back and saw what happened was the place where the water used to drop, something blocked that hole and the water was not dripping. Okay, so the daughter did not know it. She was waiting for the bowl to fill. That was the instruction given by Bhaskaracharya. So the daughter was waiting for that to fill, and that did not happen. So then that's the whole reason she did not go. The Bhaskaracharya, like though he was upset, after he came back, he realized that so there was some blockage in that like hole from where the water was dripping. That's the whole reason the bowl underneath like did not fill up. Okay, so then but Bhaskaracharya what he did was he wanted uh, he wanted his daughter's name to be permanent in the history. Okay, so what he did was he wrote a book known named he wrote a book for mathematics which he named it as Leelavati. Okay, Leelavati is the name of his daughter. So in the name of his daughter, he basically wrote this book so that like her name can be there forever, and truly children Even today, like we are buying this book. You can just go online. If you're sitting online right now, you guys are online, right? You can just go and like type Leelavati book. That's enough. So Leelavati now, Bhaskaracharya, he lived in, I don't know, like he lived almost 1,000 years ago. Like even now we are still speaking about the book Leelavati. So he was such a visionary, or like he had such an what thought process that he was very sure that this name Leelavati would remain forever, and that has happened in spite of 1,000 years now. In spite of 1,000 years, even today we are basically like reading Leelavati. So that's Leelavati book mostly consists of few fantastic techniques for you all to do mathematics. So these days I know you guys would have been hearing about Vedic mathematics, right? So Leelavati contains like many techniques for us to do calculations using the Vedic mathematics. Okay, that's about. Oh, we started with Sundial and we went to like Bhaskaracharya and Leelavati. So that was amazing. But still, children, like it would be very nice for me, instead of me speaking, I always wanted you guys to ask me some questions. Okay, so that would, what happens is then those questions will enhance our learning process. Okay, got it. Okay, so let's stop for now. Okay, so we'll see in the next class. So I might repeat the same experiments or the list of material which I sent you, because we could not do that today. Also because there's less time now, and I was little bit not happy that you guys were not asking me questions. No questions, of course you were typing. I was okay with that, but still I would be happy in case you can like ask me questions physically. Okay, fine. Yeah, Shardul tells that he cannot turn on video or turn on the mic. That's okay, Shardul. I know you might have joined from your desktop. Desktop might neither have mic or video. I completely understand that. But others could have at least done that. Okay. So at least for next class you do that. Like I would be very happy to see you guys and speak to you. Many times what happens, I myself get it out if I'm online. Okay, because uh, oh, even OJS had some problem. Okay, fine. So try to solve all these problems by next class. Okay, next class, we'll do. I'll send you the what we are planning is that from now on we'll send you the material list like on Sunday evening itself, so that you will have 1 week time for collecting the material, so that you will have the material for us to do the activity on Sunday. Okay, so that's the idea. So you will receive the next set of the material for next week's activity like today evening itself. Okay, fine, children. So see you all. See you in the next class. Okay, bye.